Hi friends, in this video we see Norton's theorem related problems. The first question is find the Norton's equivalent across A and B. So we have to find Norton equivalents across A and B. So whenever you want to find the Norton's equivalent across A and B, we will replace this remaining area. What is the area they ask? With what you call one current source with value in, right, and which is in parallel with one resistance, that is Rn or Norton. So this is the equivalent Norton circuit. So first what we have to find, R Norton. R Norton is nothing but R Thevenin. So how we will find Thevenins? We have to remove independent source and find the equivalent resistance. Here we have one current source. If you remove current source, it must be open circuited. Then we have a remaining resistor and this one. Okay. So in this then we have to find this equivalent resistor. So here we have 5 ohm, here we have 5 ohm, here we have 10 ohm. So this implies from here, if you see equivalent network, it is 5 and 5 are in series, which is in parallel with the 10. So 10 ohm parallel 10 ohm. So that is your R Norton. R Norton is equal to 2 resistor parallel means the equivalent resistance is divided by 2 of both the resistors. So it is 5 ohm. So R Norton we got, it is 5 ohm. Next what we have to find, I Norton we have to find. So I Norton is obtained by, I Norton is nothing but a short circuit current. So it is short circuit current. So we have to short the terminal and find the current. So we have to short this terminal and find the current through that terminal. So this is 10 ohm. Fine. This is 5 ohm. 5 ohm. This is 10 ohm. This is shorted. This terminal AB is short. So if you short these two terminal, what will happen? So this is a resistor in parallel with the short circuit. So the equivalent resistance will be short circuit. So this is what the equivalent circuit. So now this is 10 ampere. This is coming here and divided between these two resistors equally. So this is 5 ampere will go here, 5 ampere will go here. So the same current will flow through shorter terminal. So I Norton is equal to 5 ampere. This implies I Norton is equal to 5 ampere. So the answer is I Norton is equal to 5 ampere, R Norton is equal to 5 ohm. This is what our equivalent circuit. Okay. The next problem is determine the Norton equivalent circuit. So how we are going to find? Follow the same procedure. First we have to find what you call R Norton. We have to find. So for that we remove the circuit. We have two independent source that must be removed first. So if you remove voltage source, that must be shorted. Here we have current source that must be removed, means it must be opened. Then we have one 5 ohm, then we have one 10 ohm, 5 ohm, 5 ohm. So what it implies? It implies R Norton is equal to this 10 ohm parallel with these two are series. So 10 ohm parallel 10 ohm, that is 5 ohm. So R Norton is 5 ohm. Next what we have to find? I Norton. I Norton is obtained by shorting the corresponding terminal. That means we have to short this terminal and find the current through this terminal. So let us see how we are going to find. So I draw the circuit first. Plus minus 30 volt. Fine. This is 5 ohm. This is 5 ohm. Right here we have 10 ohm. Here we have 5 ampere current. So 5 ampere current 5 ampere current. It's going like this. Then the terminal AB must be shorted. So current flowing through this short circuited terminal is I Norton. So what we are going to find, I want this. So if these two are shorted, if this is a resistor parallel with short circuit, so it will become a shorted terminal. So the circuit will be like this. Right, I have to find the current flowing through this. Okay, first for that I apply. I find what is the voltage across this terminal. Then I apply V by R is equal to I. Right. So what we do, I apply KCL at node V. So it is V minus 30 by 5 plus V by 5 plus 5. V minus 30 for this branch, V minus 30 by 5. This is V minus 0 by 5. For this branch, outgoing current 5 ampere, that is equal to 0. This implies V minus 30 plus V plus 25 is equal to 0. So V is equal to 2.5. So what I want I. So I is equal to V by R, that is V by 5. Here 5 volt, 2.5 volt. I is equal to V by 5. The current through this branch is V by 5. So V by 5, 2.5 by 5 is 0.5. So I is 0.5, Rn is what you call 5 ohm. So the equivalent circuit is 0.5 ampere. This is 5 ohm. So the current source in parallel with the resistor. So this is the answer. Okay, we draw equivalent Norton circuit. Okay, next we find the current flowing through 1 ohm resistor. So this is a 1 ohm resistor. Here we have to find current flowing through resistor using Norton circuit. How we are going to find? Let us see. As usual, we first find what you call R Norton. R Norton is obtained by removing the independent source and find the equivalent resistance. So I remove this independent source. Voltage source I removed, it will become short. Right here, this terminal should be shorted, and this source I remove, so it will become short. Right. So this is nothing, and what happens here? We have 1 ohm resistor. Fine. Okay. So what will happen? Okay, it is not on. Okay, this 2 ohm. I have to find current through this. Okay, sorry. So this 2 ohm will be as it is, and this 2 ohm will be there. This is removed, right? So this source, if I remove, it will become open circuit, right? So this is 2 ohm. This is 2 ohm. This terminal will be opened, right? To find R Norton, because R Norton is equal to R Thevenin. Whenever you want to find the Thevenin resistance, that corresponding resistance should be removed. So it will be like this. So what is R Norton? R Norton is 2 parallel 2, that is equal to 1 ohm. Okay, next what we have to find? We have to find I Norton. So when we want to find I Norton, I use a shortcut method. You see, everything is voltage source. This is one current source. I convert this voltage source into current source. So V is 2, R is 2. So I is equal to 2 by 2. So 1 ampere parallel with 2 ohm. Here you see V is equal to 3, R is equal to 2. So V by R, 3 by 2 is 1.5 ampere parallel with 2. So I replace that. So what is the thing? 1 ampere parallel with 2 ohm and 1.5 ampere parallel with 3 ohm. So again it is 2 ohm or 3 ohm. Let us see. Okay, this is 2 ohm. Then 1 ampere, 1 ohm and 1 ampere. So this is 2 ohm. Right. This is what do you call, I want to find a Norton current, so it must be, the terminal must be shorted, the resistance must be shorted for finding the Norton current I told. So then this is 1 ampere. Now it is easy to find I Norton, that is current flowing through this terminal. You see, out of this all the three branches, this is short circuit, so all the current will flow through this circuit only. So short circuited branch. So what is I Norton? I Norton is this current and this current. So 1 plus 1.5 plus 1, so 3.5 ampere. So current flowing through this terminal is 3.5 ampere. So what we got? We got equivalent circuit, that is 3.5 ampere current source, that must be parallel with the R Norton. R Norton is already we found, it is 2 ohm. Now this resistance is what do you call, this is what load resistance, this is 1 ohm. Yes or no? This is 1 ohm, right? This I have to find the current through this resistor only. So remaining circuit I replace with the Norton equivalent. So now I have to find what is current through 1 ohm. I through 1 ohm is given by, it is parallel. So I apply current divider rule, total current into opposite resistor, right? Sorry, R Norton is, what is by R Norton? R Norton is 1 ohm. Also, okay. So 1 ohm means I replace with 1 ohm, 1 ohm. So 1 by 2. So current is equally divided 1.75 ampere. I through 1 ohm is 1.75 ampere. So no need to find apply current divider rule, since two resistors are equal and current is divided between these two, so it is 1.75 ampere. Directly you can write. Okay. So the answer is 1.75 ampere. So next question is, determine the current through resistor R using Norton's theorem. That means I have to find the current through this resistor. Okay, how we are going to find? Let us see. So first, as we do always, we find R Thevenin, right? Or R Norton. R Norton is nothing but R Thevenin. To find that, we have to remove the source. So independent, so this source I remove, so it will become like this, 1 ohm. Okay, next I have to short this. I have to remove this and I have to short this. So this will not come into picture, right? So whenever you have to find R Thevenin, that resistor must be removed. This is shorted. I remove. This is 1 ohm. This is 1 ohm. Okay. So what is R Norton? R Norton is equal to, you see these two are series in parallel with 1. So 2 into 1, 1 plus 1 is 2, parallel with 1, so 2 plus 1. So that is 2 parallel 1 ohm, R Norton. So it is 2 by 3 ohm, that is equal to 0.66 ohm. So R Norton is equal to 0.66 ohm. Next I have to find what is the current flowing through this terminal. So I have 3 sources. If I apply, I have to write 3, what do you call, 3 equations. If I apply KVL or KCL, so what I do, I apply superposition theorem. First I keep this source, I find what is the current flowing through this resistor, then I keep this, then I keep this. Okay, so apply superposition theorem, right? So by superposition, first I keep one source active, remaining source inactive. Okay, so what will happen? This is active, I keep this only active, 2 volt source. So this is what you call, here we have 1 ohm, 2 volt, right? So whenever you find a current or I Norton, that resistance must be shorted. That is short circuit current only you have to find. This will be removed. So this source is removed. This is I Norton 1 due to the terminal. Remaining source I have to remove because I am going to apply superposition theorem. Next, this resistor is there, 1 ohm. Fine. This current source I remove, it will become open. This 1 ohm I keep. So this is 1 ohm. So now I find I Norton. So I Norton is given by I Norton is equal to V by R. So here you see current flowing through this terminal is 2 ampere. So this is short circuit branch, this is a resistor branch, so all the current will flow through this. So it is 2 ampere. Why this is 2? This is I is equal to V by R, 2 by 1, 2. So this 2 is going only through this short terminal. So IN1 is 2 ampere. Next what I do, I keep this one only, discard these two. This 2 and this 1 ampere. So the circuit will become case 1, case 2, this will become short, this will become open, this resistor will be there. Okay, so here we have a 1 ohm resistor, the voltage source will be shorted. This is current IN2, keeping this source as it is. This source is 1 volt. Here we have 1 ohm and 1 ohm. Right? So what I did, I shorted this 2 volt, I removed this 1 ampere, opened it 1 ampere source. So it will be this 1 ohm, this is shorted because for short circuit current only I have to find. So this is 1 ohm, this 1 ohm, this 1 ohm will be there. So what I get, this is the circuit I am getting. Okay, now I have to find IN2, right? So IN2 is, again I find I is equal to V by R. See what is the, you see what is the total resistance? R equivalent is, these two are in series, so 2 with parallel with 1 ohm. So 2 parallel 1, so that is 2 by 3. So I is equal to V by R, short circuit current. V is 1 volt by 2 by 3 ohms, so that is 3 by 2 is equal to 1.5 ampere. Right? So IN2 1.5 ampere. Actually, this is what IN2, but what I found through this one. So IN2, this IN2 only I found, but IN2 is originally this one. Let me call this IN2 dash because I found what is the current due to this 1 volt source. So current flows from lower potential to higher potential. So this my current goes through this, but IN2 is this one. So this, let me call this current is IN2 dash, but what I want is IN2. So IN2 is minus 1.5. IN2 is minus 1.5 ampere. Okay, next what I do, I keep a third source active, other two sources inactive. That means I keep this 1 ampere active, this I short, this I short. Okay, so this terminal will also be shorted because short circuit current I want. So totally this is short, this will be 1 ohm, this 3 resistors will be there. So the circuit will be like this. Case 3, the circuit will be, this is 1 ohm will be there. This terminal is shorted, this terminal will be there, this is what IN3, this 1 ohm will be there, and this 1 ohm will be there, and this is, this current source I keep active, this is 1 ampere. So what will happen, this is 1 ampere, so what is my IN3, so here current is divided between, here this 1 ampere current comes. Since the resistors are equal, so it is equally divided, so it is 0.5 ampere. So this 0.5 ampere comes here directly. Okay, so when it flows through this 0.5 will be coming here. So what happens? IN3 is 0.5 ampere. So what is my total IN? Total IN is IN1 plus IN2 plus IN3. That is equal to IN. IN1 is we got 2 ampere, IN2 is minus 0.5, IN3 is plus 0.5. So 2.5 minus 1.5, 1 ampere. So what is my I Norton? I Norton is 1 ampere R Norton. R Norton we found as we will go and see R Norton 0.66 ohm. Resistor is load resistance is 1 ohm. So R Norton is 0.66 ohm. Load resistance is 1 ohm. The question is we have to find current through this 1 ohm. So this is parallel circuit. So apply current divider rule. I goes through 1 ohm. I goes through 1 ohm is total current multiplied by opposite resistor divided by sum of the individual resistors. So 1 plus 1.66. If you simplify, what you get is 0.4 ampere. So current through this 1 ohm is 0.4 ampere. Right? So I hope you understand all the 4 problems. If you are having any doubt, please ask me in comment section. I will clarify. Thank you.